Assalamu alaikum warahmatullah. Hello guys. This is part 2 of introduction to deep learning and let's get started. Screen webcam. Okay. In last session we talked about machine learning and AI. What is machine learning? What is representation learning? And now we will continue that thing. And before that, I want to say one thing about who should watch this video and for whom I am doing this video. This video is for guys who are students, undergrad, grad students, or computer science or like software engineer who are working. And I assume people should know a little bit of Python or other language, and they should also know about mathematics. And I want I'm doing this for my peers, for people like me who wants to, to dive into details of deep learning, not to be onto the top of this ocean, to dive into the inside of this ocean of deep learning and to study the deep and to understand that things. And there is one very good quote I want to say that Hinton Geoffrey Hinton said that the future depends on some graduate students who is deeply suspicious of everything I have said. Yeah, it might be true, and so the point is that this video is for people who are passionate about deep learning and who wants truly understand it. And if you as a person, I congratulate yourself, I congratulate you, and I wish you luck to watch all these playlists, and I believe they are very useful. And be patient, and practice makes perfect. Let's talk about historical trends in deep learning. So in fact deep learning goes back to 1940s. From that time, deep learning, people start talking about AI deep learning. One interesting fact is that we think deep learning is like comparatively new field, but it is old, and in the past we call this field as cybernetics in 1940s to 1960s. And there was one gap, unfortunately there is one winter, and then we start calling this field of deep learning like as a connectionism between 1980s to 1990s. And since 2006, this field was given the name deep learning. That's one fact. Then we will, so as you see, there is two winters between 1960s to 1980s and between 1990s to 2006. And we will cover that things, and they are very important winters. So, first winter between 1960s to 1980s. So, Rosenblatt, 1987. So he published a paper and he created this perceptron, that it is a type of classifier that uses set of inputs to make predictions about whether the instance belongs to one class or another. He created that kind of model and he gives the name perceptron based on the how human brain works. And then there were another model, adaptive linear element, ADALINE, was created by Widrow and Hoff, 1960s. It was also like early artificial neural network. It is early architectures of modern neural networks. So the important models, ADALINE and perceptron. And linear models were built on top of these ADALINE and perceptron models. But unfortunately, there was one very, very bad pitfall, disadvantage of these linear models, that they couldn't just simply learn XOR function. So what is this function? Assume we have a model, F model. We give input x, and it has weights, where if we give 0 and 1, it should return 1. If we give 1 and 0, it has weights, it should give us 1. But when we give 0 0, when we give 1 1 as input x, it should give us 0 and 0. So these models simply failed to learn this rule. So assume what weight you should give here, that this 0 1 1 0 should be 1 1, and what weight should be like unique weight that it will be 0 and 0 if we give 0 0, if we give 1 1. There is no such w, right, we can give. And so models couldn't learn that, and from that people were like disappointed about that we should think from another point of view to the models, that there was like after this there was gap of winter. This was like main reason. And after like 2 decades, neuroscience reopened their door to deep learning. Oh, good paragraph sentence, first sentence. The neurocognitron was created by Fukushima, 1980. So he introduced powerful model architecture for processing images that were inspired by the structure of mammalian visual system. And it is also the basis for CNN networks. CNN networks are like used for image classifying, and was created by Lee Kohn et al. 1998. So the neuroscience opened the door to deep learning again. So when the neuroscientists analyzed it and looked, and Mr. Fukushima tried to look to the structure of mammalian visual system and try to build based on this model architecture, and it worked. And that thing is also based, like CNN also based on that things on top of that. So that gift to scientists the motivation that we can do that. Like, let's again reopen, restart, let's continue doing this kind of research in AI. Then the central idea in connectionism is that the large number of simple computational units can achieve intelligent behavior when networks connected, when networked together. So in our case, these linear models consist of only one layer. But in 1980s, scientists thought that if we give a lot of such kind of layers, and if we connect them together, we can achieve kind of intelligent behavior. And after that, at that time, backpropagation was created, LSTM networks were created, like a little bit late. And this idea that creating a bunch of large number of simple computational units, or this kind of layers, and when we connect them to each other, we can achieve kind of intelligent behavior. That was like big motivation in 1980s. And neural networks were being explored eagerly, but they hit computational and theoretical barriers. They were difficult to train, not enough computational power, suffered from problems like overfitting and vanishing gradient problems. We will cover that problems in the future, inshallah, and required a large amount of data and computational power, which were not as readily available as today. So there will be problems like overfitting, vanishing gradient problem, and there was like data problem. Like, check in 1980s, like how strong was computer, like memory, it was very small, and computational power were also very small. So it was also problems, 3 small problems, and it made people, like to go away from that research and go to another field. And that started second winter between 1990s to 2006. And in 2006, the third wave started from Hinton et al. Hinton and his colleagues wrote paper where neural networks called deep belief network could be trained efficiently using strategy called greedy layer-wise pre-training. And after doing that thing, he proved that neural networks can be trained and we can create that kind of intelligent systems. And that gives motivation to current status of AI. And from 2006, a lot of research were going on. And from 2006, there is no winter. In 2006 to 2024, there is no break. There is no winter. It's going somewhere. So, as we said, there was limited data. So, dataset size started increasing. Like we know NIST dataset, right? It's a very powerful dataset and like basic, easy to use for now, like because we have a lot of computational power. And at that time, it was like very big dataset at that time. And now, like this kind of dataset we created, this kind of dataset like for object classification, for other things. There were datasets creating, and year by year, dataset size becoming larger and larger. And now the biggest dataset, I checked the internet, is that it has 825 gigabytes, and it is open source, and it consists of text corpus, text dataset to train LLMs. So now we have that much big dataset, 825. But in this dataset, I believe it's like 5 megabytes or less, maybe 20 megabytes, like very small, because it's like 28 to 28 pixels. It's very small. And as I said, datasets start increasing, and the layers, model architecture start increasing and increasing. If we look to here, number of parameters is like, if we look to 1951, 1954, 58, 8, and etc. till 2018, 18. If you look, number of parameters here, if it is like one and very small, it goes increasingly more parameters, and especially between 2014 2018 there is like big gap, see, like hill, very dramatic increase. And now in 2014, I believe it's much more greater. Like there are many LLM models, their size are like billions and a lot. For example, if we check the ChatGPT 3 has 175 billion parameters. And like, for example, Llama 3 has like 3-4 models, 7 billion parameters, 13 billion parameters, 70 billion parameters. And if we compare to parameters of human brain, that human brain has 86 billion neurons. Each neuron forms about 1,000 to 1,000 synapses with each other neurons, resulting in approximately 100 trillion synapses in total. If we assume that these kind of synapses are parameters, if we represent synapses as parameters, we can compare that human brain is 1,000 times more, has more parameters than currently GPT-3. GPT-4, GPT-4o, I'm not sure how many parameters they have, because I think it's secret. And that's all for today. So conclusions, thank you for your effort and for your time. So we talk about the history, about 2 winters between 1960s to 1980s and 1990 to 2006. And that winters give very big boost to the improvement. And the important boost is given by 2006 by Hinton, and we call Hinton, Mr. Hinton, as Professor Hinton, as father of deep learning for this thing mainly, and for his big contributions, of course. And that's all for today, guys. So on the webcam, That's all for introduction. Check another video, go to another video on the playlist, and enjoy videos, make notes, and read from book. So if you go to deeplearningbook.org, you can see e-version of each chapter, and if you read chapter in more details, it is very clearly stated, and I'm sure my explanations, video explanations, makes you understand it more clearly. If you like, enjoy, share with friends. Have a good day. You are the best.